Hello everyone, and welcome to another installment of Physiology Friday, a weekly newsletter and now video series where I break down a recent study that I found interesting or particularly noteworthy. Before I get to today's study, just a quick reminder that if you're enjoying this content and would like a way to show your support, you can do so in multiple ways. These include becoming a monthly supporter on Patreon or making a one-time donation through PayPal. You can find links to all of these support options in the description below. Another way to show support is to patronize the sponsors of this video and my podcast. My current partnership is with Element Electrolyte Drink Mix. Right now, my audience can snag a free sample pack of Element electrolytes by using the link in the description below. That is drinklmnt.com/scienceandchill. You can also use this same link to order Element by the box if you've already tried your sample pack, or try out some new tasty flavors. My two favorites and recommendations are the watermelon and the citrus salt, but they have many more flavor options on the website, so I would really encourage you to check out the website and try a few of those. Alright, let's get to today's discussion, which focuses on a study investigating whether supplementing with exogenous ketones may have benefits for brain blood flow and cognitive performance in obesity. The metabolic and cardiovascular harms of obesity are well known, which is quite alarming given that obesity rates in the US are somewhere around 40%, with similar statistics around the world. Obesity also poses a danger to brain health, increasing the risk for cognitive impairment and cognitive decline. Why this occurs could be due to several reasons, but in part is proposed to involve reduced blood flow to the brain and lower levels of a molecule known as brain-derived neurotrophic factor, or BDNF, which has been called by some, quote, miracle grow for the brain, because of its effects on the growth and the strength of neurons. Along with reduced blood flow, hyperglycemia, or elevated blood glucose, following meals can also impair cognitive function and negatively impact acute and chronic brain health. Obese and diabetic individuals may also suffer from insulin resistance, which reduces glucose availability to the brain and impairs brain metabolism. While these effects are more pronounced in obesity and other metabolic disorders, all of us are concerned with maintaining, or better yet, improving our brain health and cognitive abilities. Supplements for brain health and performance are pretty scarce, as is the research to support them. However, exogenous ketones are gaining popularity as a supplement with potential neurological benefits. Our body produces ketones when we are in a fat-burning state, which can be leveraged through fasting or a very low carbohydrate or ketogenic diet. When one is in ketosis, the liver is using fatty acids to produce ketone bodies, beta-hydroxybutyrate, or BHB, being one of them, which can then be used by muscles, the heart, and the brain for energy. In particular, the brain seems to readily utilize ketones for energy and does so quite efficiently. This alternative energy source might be superfuel for the brain and the body. We see here that we can experience both endogenous and exogenous ketosis. Endogenous meaning that our body is producing ketones on its own in the liver, and exogenous meaning that ketones are coming from an outside source. In the case of our discussion today, that outside source is a ketone ester, which once ingested can be metabolized by gut esterases and deliver ketones directly into our circulation, which can then be metabolized by the brain and other tissues. Now, very few studies have looked at how prolonged ketone supplementation may impact brain health and performance. Some acute infusion studies where BHB is infused at a high dose into the body suggest beneficial effects, but the impact of elevating ketones via supplementation over weeks to months are not well established. A new study published in the Journal of Physiology investigated the impact of a 14-day ketone supplementation period on markers of brain blood flow and cognitive performance in a group of otherwise healthy adults with obesity. The title of that study, which you can see here, is Short-Term Ketone Monoester Supplementation Improves Cerebral Blood Flow and Cognition in Obesity, a randomized crossover trial. And that study was just published on the 4th of October of this year. Let's take a quick look at the study methods and the design. This was a randomized, placebo-controlled, crossover, counterbalanced study. Quite the mouthful, but what this means is that All participants completed both the experimental and placebo conditions, did so in a random order, and neither the investigators nor the participants were aware of which condition they were in until the end of the study. There were two different experimental conditions, each lasting 14 days. In the ketone supplement condition, participants consumed a ketone supplement 3 times per day, once before breakfast, once before lunch, and once before dinner. In the placebo condition, participants consumed a taste-matched placebo supplement 3 times per day for 14 days, as in the ketone supplement condition. Now, a major strength of this study was the strict control over diet. All of the food consumed by participants during this study was provided by the researchers and contained approximately 50% carbohydrate, 30% fat, and 20% protein. Study measures included cerebral blood flow, measured using ultrasound in the common carotid, vertebral, and internal carotid arteries. Cognitive performance was measured using 3 different tests: the Digital Symbol Substitution Task, abbreviated DSST, the Stroop test, and the Task Switching Test, or TST. All of these tests have been shown to reliably measure aspects of cognition, including working memory, processing speed, selective attention, and inhibitory control. Finally, BDNF, brain-derived neurotrophic factor, was measured in serum and plasma. All of these measures were taken pre- and post-intervention. All right, now let's take a look at some of the study results. Regarding the test of cognitive performance, we can see here that scores on the DSST significantly improved after the ketone supplementation condition. However, no differences were observed during the Stroop test or the TST. Moving on to results for blood flow. Flow in the common carotid, abbreviated CCA, and vertebral, abbreviated VA, arteries was elevated after the ketone supplementation condition. In addition, vascular conductance and shear rate increased in the vertebral artery following ketone supplementation. Now, interestingly, the blood flow increases in the common carotid and the vertebral arteries was correlated with improvement on the DSST, meaning that higher levels of blood flow were associated with greater improvements on this cognitive test. And finally, there were no significant changes observed in BDNF in either the ketone or the placebo condition, whether measured in serum or plasma. As far as I know, this is the first study to look at the cognitive effects of supplementing with exogenous ketones, at least in a population that is more or less healthy. Now, by this, I mean that although they were categorized as obese, none of the participants in this study had any indications of cognitive impairment, nor did they have any other comorbidities, or for that matter, even have elevated blood glucose. For this reason, I would consider maybe generalizing these findings to, quote, healthy adults in terms of how ketones might impact brain function, and this is quite promising. The keto diet and fasting are both purported to help with mental clarity, performance, focus, and other measures. And exogenous ketones are more appealing, in my opinion, because they can be used as a nootropic or cognitive enhancing supplement without requiring much lifestyle modification. It's one thing to improve cognitive function in someone with low function at baseline, and another exciting thing to enhance cognition in normally functioning individuals. The results of this study suggest that the improvements in cognitive performance were caused in part by elevated blood flow to the brain. The same group who conducted this study has also published that exogenous ketone supplementation improves peripheral endothelial function, measured as brachial artery flow-mediated dilation, in the same group of participants. Add cardiovascular benefits to the cognitive benefits of exogenous ketones, and you start to build a pretty compelling case for regular, i.e. daily, supplementation with ketones. Right now, this may not be feasible due to the somewhat cost-prohibitive nature of exogenous ketones, which go for around $8 a serving for the cheapest commercially available product. However, companies are developing more cost-effective alternatives that could be promising. For now, watch this space. Just a quick note that the supplement used in this study was disclosed and is the ketone monoester sold by HVMN, also known as Health Via Modern Nutrition, Full disclosure that I have no financial ties to HVMN as a company, though I have done work for them as a freelance content writer in the past. That concludes today's discussion. Please, if you enjoyed this video, don't forget to press the like button and subscribe to my channel to get updates whenever new videos are released. Also, I would love to hear any comments you have about this video or the study discussed today, or any recommendations for studies to cover in a future video or newsletter. See everyone next time.